All right, so we've done a lot with sine functions. We have used law of sines. We have used sine as part of SOHCAHTOA to solve different types of triangles. Now we are going to be graphing sine functions, and our learning goals are to be able to identify the period and amplitude of a given sine graph or given sine equation. We also need to be able to write the equation and graph a sine curve by hand, given its characteristics. I cannot stress enough the by hand. This will be on the non-calculator part of your test. So yes, you cannot rely on that graphing calculator. Before we talk specifically about our sine parent graph, I want to just talk about periodic functions in general. A function is periodic if its graph has a repeating pattern that continues indefinitely. So if I look at this, this graph, if I put a scale on here, say this is 1, 2, 1, 2, 3, 4. If I look at its values here, f of 0, so when x is 0, y is 0. When x is 1, y is 2, so f of 1 is 2. F of 2 is back down to 0. F of 3 is back up to 2. And f of 4 is back down to 0. So you can see this is an example of a periodic graph because it has a repeating pattern. So if this kept going on forever with these little triangle mountains, this would be periodic. So it goes up and back down and then starts over again at the same rates, same shape. The period of a function, it's important that you understand.
Sarah Harris, you have a call on Park 7000. Sarah Harris, Park 7000.
Sorry, could not get the pause button fast enough to cover that up. The period of a function is the horizontal length of each cycle. So however long each cycle is, that is what its period is. So now let's look specifically at our sine curve. This is going to be our parent graph. A sine curve, if I am going to graph it, it has a period of 2 pi, and I'm going to show you why in a second. If we think about the unit circle and our quadrantal angles, which have those coordinates that I'm writing over here, a sine curve, if I go around the circle from 0 to pi over 2 to pi to 3 pi over 2 to 2 pi, so those are going to be my x values. So pi over 2, pi, 3 pi over 2, 2 pi, and then the same in the other direction. Here's negative 2 pi, here's negative pi, and then you've got the ones in between. At 0, the sine of 0 is 0 because it's the y coordinate. So I could make an ordered pair right here. When x is 0, y is 0. When I move to pi over 2, the sine of pi over 2 is 1. So go up at pi over 2 to 1. At pi, the sine is back to 0. At 3 pi over 2, the sine is negative 1, so it goes down. And then at 2 pi, it returns to 0. This is one full period of a sine curve. Now, do not try to say that just this hill is a period. It is not, because a period is the horizontal length of a full cycle, and a sine cycle goes up, then down, and then back to starting point and goes over. So this, from 0 to 2 pi, is a full cycle. The cycle could go the other way as well. So down to negative 1, then up to 0, up to 1, back to 0. Again, there's a full cycle. A full cycle of a sine wave has both a hill and a valley. So if you only have a hill or you only have a valley, you do not have a full period yet. If we look at this graph, the domain is all real numbers because this pattern goes on forever. It keeps repeating this cycle. The range, though, is very restrictive. The highest y value I have is 1, and the lowest y value I have is -1. So my range we express as a sandwich between -1 and 1. The maximum value, which is 1, occurs for the first time at pi over 2. But if I keep going, it would occur again at 5 pi over 2. And then again another 2 pi later. It would happen every cycle. And so that means every period it's going to hit that same value. So if I wait 2 pi, it'll be back up. So we call that plus 2 pi n, because n could be any number. So at every 2 pi after the first one is when I'm going to have a maximum value. The minimum value, which is -1, very similarly, the first time we hit the minimum value over here is at 3 pi over 2. And again, we'll hit it again every 2 pi, so plus 2 pi n. Now, we call the max value, we label that with a capital M, the min with a lowercase m. Amplitude is found by taking half of the difference of the max and the min values. In this case, the max is 1, the min is -1. 1 minus -1 is 2, and half of that is 1. This is the formula for amplitude, but we very rarely use that because amplitude, when we're looking at the picture, is how tall it is from the midline to the hill top or from the midline to the valley. It's 1 unit from the midline to the valley, and it's 1 unit from the midline to the hill. So that would be 1 unit in this particular case of our parent graph. Now, parent graphs, remember, are the most simple versions. This is our standard sine curve equation. We can have an A and we can have a B. Now, in pre-calc and a little later in 14.2, we will learn some additional changes that we can make to sine curves. But for right now, we're just worrying about the A and the B. The A is the number that's in front of the sine, and that is actually equal to the amplitude. B is what we use to get the period. We take 2 pi and we divide it by whatever is in front of the x, and that's going to give us the period. Because even though the parent function has a period of 2 pi, not all sine curves will. So that's our first task, to look at this equation and find the amplitude and find the period. So we've got 2 of these. I'm going to do this one first because it's a little harder, and then I'm going to have you try this one on your own. So amplitude, we can't really make that harder. The amplitude is the A value, and the A value here is 1/3. So the amplitude is 1/3. The period, remember, we find by doing 2 pi divided by B. Well, I've got this like crazy divided by 4. Remember that means that B is 1/4. So I'm taking 2 pi, dividing it by 1/4, which is the same as multiplying by 4. So 2 pi times 4 is 8 pi. So I have an amplitude of 1/3 and a period of 8 pi over here. I would like for you to quickly use those same ideas to find the amplitude and period for example 1a. So pause it, do it real quick, and then come back to check your work. All right, amplitude is A. A in this case is 5, so that's our amplitude. Period is 2 pi divided by B. In this case, there's no number in front of the x, which means B is 1. 2 pi divided by 1 is 2 pi. So here, amplitude is 5, period is 2 pi. All right, so those are quick, simple. Now we're going to actually start doing some graphing. So we've got two graphing examples here. We start the graphing examples the exact same way we start example 1. We identify the amplitude and the period because we need those in order to graph it. So here, amplitude is 2. The period is 2 pi divided by 1, so 2 pi. The reason we need these, the amplitude tells you the max and min values on your y-axis. So I need to get up to 2 and down to -2 on my y-axis here. The period tells you what you need to get to on each side of the x-axis, because when we graph these, you have to have one full period on each side. So I need a full period on the right of 2 pi, so I'll mark my halfway point also, and on the left side also a full period to get to the -2 pi. Now, you don't have to do what I did with the unit circle in our parent graph. I just wanted you to see the connection between the unit circle and the graph. Now, when I graph these, I know where it's going to start because my sine curve is going to start at 0, 0, because the sine of 0 is always 0. But because my amplitude is 2, at pi over 2, I am going to be going up to 2 instead of up to 1. And then at pi, I'll be back at 0. At 3 pi over 2, I'm going down to -2. And then at 2 pi, back to 0. And then if I connect it, looks like this. And then if I do the other side to match, down, middle, up, middle, and then connect. So there would be my graph of my sine curve. Let's do one more of those. So here my amplitude, the number in front of the sine is just 1. My period is 2 pi divided by, in this case, 4. So I need to reduce that. 2 and 4 both divisible by 2. My period is pi over 2. So that's a change from my parent graph. That's okay. Again, amplitude, we label the y-axis with. Period, we label our x-axis with. I need to get to pi over 2 and -pi over 2 on each end. So in between would be pi over 4, 45 degrees, -45 degrees. So if I need to get in a full cycle, again, I do the exact same thing. I need 4 little places. I start at 0, 0. I go start, up, middle, down, middle. Over here, middle, down, middle, up, middle. So then I just got to draw in my wave here, making sure I make the right shape. Arrows on both my ends, and there is my graph. All right, last ones, we're not graphing, we're just writing the equation. So it gives us the amplitude, and it gives us the period, and we have to be able to find our equation in the form y equals a sine bx. The a part is super easy. You just put it in front. The b is, you have to show a little bit of work because the period, remember, equals 2 pi over b, and b is what I need. So if I'm solving for b, I better know my period, which I do. So plug that in. 10 pi equals 2 pi divided by b. So if I want to get b alone, I can do the little switcheroo here. b equals 2 pi over 10 pi, and then just reduce. The pi's cancel. 2 over 10 is 1/5. So that means b is 1/5. I know that my a is 3. So y equals 3 sine of 1/5 x, which would be x over 5. So 3 sine x over 5. All right, last one. Amplitude, which is my a, straightforward, given to me. period. Again, I set this equal to period equals 2 pi over b. Now this one, because the period is a fraction, I think that these ones are easier to solve using proportions, but you can certainly make your own choice. So 5 pi times b equals 8 pi. So to get b alone, I would be dividing by 5 pi. So b equals 8 pi over 5 pi, and then the pi's cancel. So you just have 8 over 5. So now just write the equation. Y equals A, which is 4.5, sine of 8/5 x, which would be 8x over 5. Okay, so again, please, please, please pay attention to how we solved for this b, because it's important that you remember to take the period and set it equal to that 2 pi divided by b so that we can come up with our correct answer. So here it is, and boom goes the dynamite.